So what we're trying to do is explain oxidation, to understand oxidation. And in order to do that, let's consider a very simple chemical reaction, the reaction of magnesium with oxygen. Here's a video from NCSSM Online that shows that reaction.
Group 2 metals also react rapidly with oxygen in the air when they're heated. Magnesium is flammable
Oh, what happened? All right, so there's your reaction equation. Mg plus O2 gives you MgO. Now let's look at that. Let's consider that reaction. Mg plus O gives you MgO. So we have an Mg. Oh, nope. Let's use our brush. Mg reacts with oxygen. Oxygen we know is diatomic, so it's O2 to give you MgO. And to balance this reaction, we want to maybe put, since we have two oxygens here, we want there to be two here. So we put a 2, and then we put a 2 there as well. And so now it's balanced. Now this is a simple oxidation reaction. This is an oxidation reaction. And the fact that it's an oxidation reaction is fairly intuitive, right? It's fairly obvious. Why? Because we've reacted something with oxygen. Oxidation is to react with oxygen. So oxidation on a first level, on the most fundamental, well, not the most fundamental, on the most maybe superficial level, oxidation is a reaction with oxygen. Or you could think of it as a gain of oxygen. People might also say gain of oxygen. And that's the superficial level, because if you look deeper, if you look at what's happening with the electrons, you'll see that what's actually happening is oxidation is the loss of electrons. Why is that? Well, where is oxygen in the periodic table? Oxygen is here, group 6. It's so close to getting to the neon configuration, to getting its perfect 8 outer shell. And so oxygen is pretty electron hungry. It's so close. It's really electron hungry. So oxygen turns out to be one of the most electronegative or electron hungry elements on the periodic table. And so if oxygen is coming to bond with you, it's not coming to give you electrons. It's coming to take your electrons, because oxygen is really hungry. It really wants your electrons. So again, if you're bonding with oxygen, chances are you're probably going to be losing electrons. Losing electrons. So then another definition of oxidation is really to lose electrons. And to understand that on a deeper level, let's draw out the what's happening with the electrons in this reaction up there. So first of all, what does Mg look like? Mg is in group 2 and period 3, and so it has 2 outer shell electrons. So let's draw Mg over here. Let's draw Mg. Let's use a black color. So we have Mg. And its electrons we'll draw in pink. So it has 2 electrons, 2 outer shell electrons. And then O2, we'll just draw one O for now, with 6 outer shell electrons. 1, 2, 3, 4, 5, 6. Now, how do we get this O with 6 outer shell electrons? Remember, normally oxygen is diatomic like this. So normally you have this is one bond, that is one bond. And the reason why oxygen does this is because now it gets to have basically 8 electrons. And this guy also has 8 electrons, if you count those electrons twice. So sharing is caring, and sharing is a nice way to bond sometimes. Let's push that to the bottom. Okay? But let's imagine now that one of these guys has broken up into 2. One of these oxygen molecules is broken up into 2 atoms. This oxygen atom is hungry for electrons now because it only has 6 and it's so close to getting its 8. Hey, look at that guy. That guy has electrons. Magnesium has electrons. And so what oxygen is going to do is oxygen is simply going to take them. Thank you very much. I'll have those. So oxygen takes those electrons. And now, because oxygen has gained 2 negative things its charge is now negative, and magnesium has lost two positive things. Its charge is positive. Remember that magnesium is kind of happy to be in this situation anyways, because if you look at the periodic table again up there, zoom in, magnesium has two outer shell electrons. If it loses those two, then it gets to have the perfect 8. That's just right under. Okay, so it gets to look like neon, the noble gas. And remember that most atoms really just want to be noble gases. They want to be kings and queens. So now we have Mg2 plus O2 minus, and these two can bind together. They're happy together by an electrostatic attraction. And so this is what we call an ionic bond. And remember that we said that oxygen came from the breaking apart of this O2 molecule. And so the second oxygen is going to have to find its own magnesium and bond with its own magnesium to form another MgO molecule. Another MgO molecule. And that is where we get this two MgOs from. So we have two MgOs reacting with two Mgs, one O2 molecule. And so now notice, oxidation is the reaction with oxygen. Magnesium has reacted with oxygen, but what it's really done is it's lost its electrons to oxygen. If oxygen is binding to magnesium, its agenda is to steal magnesium's electrons. And it has done just that. And so we can say that magnesium has been oxidized. Okay, magnesium has been oxidized. Why? Because first of all, it reacted with oxygen, and also it lost its electrons. And again, the chemists want you to understand that this is basically the same thing. In most cases, this is basically the same thing.